Okay, the graphs today are actually going to look like this here, which I don't know if you've ever graphed anything like this. Probably not. Anybody graph something like this? Nope. Okay. So on this graph, we have a horizontal asymptote right here and vertical asymptote. And asymptote is just like a guideline. It's a guideline where the actual graph line never touches, but it gets really close to. And then the actual things we're going to be graphing are like this line and this line. And again, these lines get really close to asymptote, but technically never touch, even though when I just drew it, it touched, but in real life, it doesn't touch. Okay, so how the heck do we graph that? We break it up into parts. Here's the steps over here. Find the asymptotes, which we're going to do, find the intercepts, and then find extra points if needed. So there's the 3 steps. So first is to find the asymptotes. There's going to be a vertical asymptote and a horizontal asymptote. For the vertical asymptote, all we do is we take the denominator and we set that equal to 0 and then solve for x. So x equals -2 in this example. And then for horizontal asymptote, this is where it gets a little bit more complicated, but I promise like by the second or third example, it won't feel so bad. When we decide what the horizontal asymptote is, we are looking at whether this is bottom heavy, top heavy, or same. And what that means is we look at the x's right here. So x and x squared. This is bottom heavy because x squared is on the bottom. There's more x's on the bottom than the top. Whereas this one, we compare x squared to x. This one's top heavy because x squared is on top and there's less x's on the bottom. And then for same, we have x squared, it's the same. So in that case, we follow a different rule. Okay, so once you establish whether it's bottom heavy, top heavy, or same, then you use this. So if it's bottom heavy, then the horizontal asymptote is y equals 0. If it's top heavy, there's no horizontal asymptote. And if it's same, then in this example it's this, but it's just the 2 coefficients, 3/2. Okay, so on your paper you should have like all the highlighted stuff and the circle stuff, if you are writing it on your own. So if you're writing this on your own, you definitely need this as a reference. So quickly jot it down. Okay, so we're going to start looking at the examples. For the first 2 examples, we're just going to find these values, and then the third and the fourth example, we're actually going to take these values and start graphing with them. So for the first example, we're just practicing finding the different ones. For vertical asymptote, that's where you take the denominator and set it equal to 0 and solve for x. That's supposed to say -1/2. Okay, x equals -1/2. Okay, then horizontal asymptote, that's where you decide whether it's same, bottom heavy, or top heavy. And these x's are the same. So same, which means y equals those 2 coefficients, 4/2, which just simplifies to 2. So y equals 2 for the horizontal asymptote. Okay, and then for x-intercept and y-intercept, if you recall, to find the x-intercept, you find it when y equals 0. So we're going to plug in 0 for y here. 0 equals 4x minus 5 over 2x plus 1. And then we solve for x. Okay, so to solve for x in this situation, you could multiply both sides by the denominator here, 2x plus 1, multiply this side by 2x plus 1. This cancels, and then 2x plus 1 times 0 is just going to be 0. So we just get 0 equals 4x minus 5. And then we solve for x. X equals 5/4, and this is actually goes into the, is like a coordinate. So when y equals 0, x is 5/4.
How come it says 0 doesn't like plural zeros?
What's that?
Like is there more than 1 0?
Some examples there are, but not this one. And then y-intercept. The y-intercept is when x equals 0, so we take the same equation, plug in 0 for x. So y equals 4 times 0 minus 5 over 2 times 0 plus 1. So this would equal negative 5 over 1, or y equals negative 5, and our coordinate looks like that. Next one, now we just repeat the steps. So here's when it starts feeling like, oh, okay, I got this. Vertical asymptote is where you take the denominator and set it equal to 0. Then you get x equals 2. Horizontal asymptote is where you look at whether it's top heavy or bottom heavy. It's top heavy, so go up to your rules. And for top heavy, there's no horizontal asymptote, so none. Then Xintercept, so when y equals 0, so we'll plug in 0 for y. I'm going to show this step, but honestly, once you get the hang of it, you don't need to like write all this out. Okay, this cancels. This is just 0. So 0 equals x squared plus 5, or x squared plus 5 equals 0. We take 5, put it on the other side. X squared equals negative 5. Take the square root of both sides. And x equals, here's where it gets kind of weird, plus or minus I squared of 5. Which is not a real number. So the answer is just Xintercept, no real number. Sorry to throw you off with that one. Okay, y-intercept gets normal again. So for y-intercept is when x equals 0, so we're plugging in 0 for the x's. Y equals 0 squared plus 5 over 0 minus 2. Y equals negative 5 halves. So 0, negative 5 halves. Okay, so we're doing the same process to start. So for vertical asymptote, we're taking the denominator and putting it equal to 0. 2x plus 1 equals 0. Yeah. So we get x equals negative 1/2. And then for horizontal asymptote, I'm looking at the x's, and they are the same. So therefore, y equals 3/2 will be our horizontal asymptote. Then for x-intercept, that's when y equals 0. So 0 equals 3x minus 5 over 2x plus 1. This just cancels. So we get x equals 5/3, which the coordinates would be 5/3, 0. Then for y-intercept is when x equals 0.
That's pretty easy.
Cool. Yay. Okay. So now that we have those numbers, now we're going to look at how to graph it. For vertical asymptote, we go to x equals negative 1/2, which would be in between 0 and negative 1, so right here. And we just draw a vertical dotted line.
Why is it dotted?
What's that?
Why is it dotted?
I don't know. Because we're cool like that.
Will it always be dotted? The vertical asymptote?
Yeah. And then for horizontal asymptote, it's at y equals 3/2. So 3/2 would be 1.5, 1.5. So y equals 1.5 would be right here. And horizontal line. So that's just a guideline. Now we're going to graph the x-intercept and y-intercept that we have. This is at 5/3, so not quite 2, a little less than 2, 0. And 0, negative 5, 0, 1, 2, 3, 4, 5. So using these guidelines, I can graph this like this. So I got that. And then there's actually another line that'll go here, but we don't know any of the points for that. So we're going to choose some x values that would make it fall over here. So maybe like -2 and -3 to get some values over in this quadrant.
Does it matter which ones you choose?
Mm-mm. Okay, so using these two values, we're going to plug this into this equation and find the y value. So y equals 3 times -2 minus 5 over 2 times -2 plus 1. Get 11/3. Graphing 11/3? What? But when I put 11/3 in the calculator, I'm just going to take that rounded answer there, 3.67, and I'll work with that. And then for -3, Same thing, plug it into the equation. Then using these coordinates, I'm going to plot some points on the graph. Okay, there we go. We're only going to do one more of these today. You ready? Or not yet? Not yet. Pause. Okay, let's do it again with this guy. So vertical asymptote, we're just taking the denominator, put an equal to 0, and then we get x equals -1. Cool. Horizontal asymptote, we're looking at whether it's top heavy or bottom heavy, and it is top heavy, top heavy. So looking at our rules over here, top heavy, none. Okay. Then x-intercept, do it when y equals 0. I'm not even going to write the denominator. I know it's just going to cancel. So x squared minus x minus 6. To solve this for 0, I'm actually going to need to factor it and put the two factors equal to 0. So to factor this, -3 and 2, when multiply to this, add to this. So x minus 3, x plus 2. Put these both equal to 0. And you get x equals 3, x equals -2. So your coordinates 3, 0, and -2, 0. Then for y-intercept, y equals 0 squared minus 0 minus 6 over 0 plus 1. So y equals -6, 0, -6. Okay. Then we graph what we got. Vertical asymptote is at x equals -1. Not her. And then put a dotted line. There is no horizontal asymptote. Our graph is going to look a little bit different. It's going to look more like this, just FYI. So that's where we're headed with this. I'm going to plot the points that I have so far. We don't really have enough here to graph the lines correctly, so we're going to just choose some numbers and solve it out to get some more points. So I'm thinking this goes up this way, but I want to just verify that, so I might choose 1, 2, 3, 4, 5, and maybe 1, 6, 7, 8, 9. So 5 and 9 on this side. And then over on this side, -4, and -6. And then taking these numbers, we'll plug it into this expression. Something that Miss Adams did on her answer key is instead of using this, which can have some big numbers, she just used the factors here, which I thought was kind of smart. So 5 minus 3, 5 plus 2 over 5 plus 1. Point 3 repeating. 2.3. And we could plug these in, or I could just give you the answers. The answer here is -4.7, and this one's -7.2. So if you want to solve it out, go ahead, but. Okay, then using these coordinates, we'll graph these. I don't know. What do you mean? 1, 2, 3, 4. Just graph as close as you can. Like 4.7 would be in between 4 and 5. Closer to 5. And then... yeah. Okay, we're going to stop there. You can get a laptop, get your homework started. There's not that many questions in the question bank, so when you do your homework, if you have to do it multiple times, you're going to get kind of the same questions over and over. So yeah.